All right, let's untangle a massive regulatory knot today in this explainer. We are looking at the realities of deploying autonomous forklifts across the European Union and the United States. If you're an engineer, a manufacturer, or an integrator in material handling, you're already well aware that shifting from human-operated machinery to fully autonomous cyber-physical systems is a massive technological leap. But actually, it's also a massive legal leap. You're stepping out of the traditional mechanical engineering domain and diving headfirst into a highly regulated, software-driven ecosystem. So today, we're going to break down exactly how you navigate this transatlantic divide in certification. Here is our roadmap for decoding all these regulations. First, we'll cover the autonomous forklift boom. Then, EU versus US safety philosophies. Next up, decoding the safety standards, followed by third-party testing and certification. Then we'll hit costs, timelines, and delays, and finally, your market entry strategy. Okay, kicking things off with Section 1, the autonomous forklift boom. To really grasp why these regulations are shifting so incredibly fast, we have to look at the immense pressure that's driving warehouse automation in the first place. For way too long, the warehousing industry has just accepted an outdated and frankly highly dangerous operational model, and the data completely proves it. 34,900. That's the staggering number of serious injuries caused by traditional human-operated forklifts in the US alone every single year, alongside 85 fatalities. And beyond the unimaginable human cost, the National Safety Council estimates that just one medically consulted workplace injury costs around $44,000, with a fatality costing a company over $1.4 million. When you have a system that puts the immense responsibility of safely maneuvering a 10,000-pound vehicle entirely on a human operator, someone who, is subject to fatigue, distraction, and blind spots, well, these numbers are the tragic yet totally predictable outcome. Which brings us to this quote from Balio that really hits the nail on the head. It brilliantly illustrates why the industry is rushing toward automated guided vehicles and mobile robots. The time for incremental safety improvements like a better vest or a slightly louder beep is over. The industry is moving toward autonomous systems equipped with 360-degree LiDAR and fatigue-proof operation. But this massive technological shift is leaving regulators scrambling to catch up, which creates the incredibly complex transatlantic divide we're about to explore. Moving right along to Section 2, EU versus US safety philosophies. This is where things get really fascinating, because the European and American legal philosophies are literally opposites when it comes to keeping these robots safe. And honestly, you just can't successfully launch a product globally without understanding this fundamental difference. Think of the EU as a strict gatekeeper. They operate on a preventative, harmonized paradigm under the new Machinery Regulation 2023/1230. This means the responsibility falls squarely on you, the manufacturer, to prove safety, generate a full technical file, and apply a CE mark before your product ever sees the market. The US, on the other hand, is more like a decentralized maze. There is no centralized pre-market certification law. Instead, the US relies heavily on the employer's liability to provide a safe workplace under OSHA's General Duty Clause. This is backed up by voluntary consensus standards and post-market regulatory oversight. Section 3, decoding the safety standards. So, let's get into the technical rules and decode the alphabet soup of functional safety standards that actually govern these robots on the ground. In Europe, ISO 36914 is the undisputed gold standard for driverless industrial trucks. If you want that CE mark in the EU, complying with the standard is absolutely mandatory. It strictly demands a formal hazard analysis aligned with ISO 12100, and it requires that electronic safety functions hit a verifiable performance level, or PLR. It basically brings AGV safety into alignment with super strict machinery safety engineering practices. Meanwhile, over in the US, while older vehicles might still use ANSI B56.5, ANSI R15.08 emerged specifically to handle modern autonomous mobile robots. Why the change? Because traditional AGVs just stop when they see an obstacle. Modern AMRs dynamically route around them. R15.08 was written to establish the rules for these intelligent behaviors, defining crucial concepts like safety-rated monitored speed and safety-rated monitored stopping for highly adaptive systems. So here is the absolutely crucial point. While both regions want the exact same safe outcome, their engineering frameworks for actually proving that safety don't perfectly overlap. Europe strictly mandates the ISO 13849 Performance Levels Framework, which is enforced centrally by the Machinery Regulation. The US leans on control reliability and consensus standards like R15.08, enforced indirectly by OSHA and employer liability. It is a completely different regulatory language to achieve the exact same engineering goal. All right, Section 4, third-party testing and certification. Once you've designed your forklift to these differing standards, who is actually checking your homework? This is where the divergence between the EU and the US becomes incredibly practical. Under the new EU machinery regulation, if your autonomous forklift uses standard deterministic control logic, you can use Module A. This is great because it lets manufacturers self-declare compliance and apply the CE mark themselves. But, and this is a huge but, if your robot uses self-evolving machine learning or AI for its safety functions, self-certification is strictly prohibited. You are pushed straight into Annex I, Part A. That means an independent, third-party notified body must step in, thoroughly audit your algorithms, and conduct physical testing before you can even think about launching. Over in the US maze, things are entirely different. While you generally self-validate your functional safety and software logic, you absolutely cannot skip third-party testing for the hardware. You must hire an OSHA-approved nationally recognized testing laboratory, an NRTL, like Intertech or UL, to physically test the electrical system, the lithium battery integration, and the fire safety mechanisms under strict standards like UL 3100 or UL 583. No way around it. Next up, Section 5. Costs, timelines, and delays. Let's look at how all this translates into real-world financial impact. Because, let's be real, understanding the rules is only half the battle. Budgeting for them is what keeps your company afloat. Look at how wildly these compliance timelines vary. If you have standard control logic, the EU Module A self-certification is the fastest route by far, taking just 8 to 16 weeks. Getting your physical hardware through a US NRTL lab takes moderately longer, sitting around 16 to 24 weeks. But if you introduce self-evolving AI into European safety systems, you hit a massive, massive bottleneck. Those notified body audits required for AI take 12 months or longer to complete. And the cost data paints a pretty stark reality alongside those timelines. Self-certifying in the EU is the most cost-effective option, usually between 5,000 and 15,000 euros. Entering the US carries a much higher base cost, starting anywhere from $33,000 to over $65,000. Simply because you are legally required to pay for that physical lab testing for electrical safety. However, Europe's AI pathway is by far the most expensive overall. You're easily looking at exceeding 100,000 euros due to specialized software auditing fees and recurring notified body surveillance. Which leads us perfectly into Section 6, your market entry strategy. So, armed with all these numbers, these differing safety frameworks, and these contrasting legal philosophies, how do you actually plan your transatlantic market entry? Well, let's turn this data into a concrete playbook. Your entire strategy depends squarely on your technology architecture. If you're building standard deterministic robots, target the EU first. You can scale beautifully across a massive unified market using that cheaper, faster Module A self-certification. But if you're building highly adaptive, self-evolving AI robots, you might actually want to deploy in the liability-driven US market first to completely bypass Europe's 12-month notified body delay. Just keep in mind, if you go to the US, you have to budget for those NRTL laboratory fees on day one. And if you go to the EU, make sure your technical file meticulously logs every single software change to satisfy market surveillance requirements. I'm going to leave you with that thought today to challenge how you align your engineering with these stark regulatory realities. Safety and automation are definitely the future, but getting there safely requires bridging two very different legal worlds before you even write a single line of code. Thanks for diving into this explainer with me today, and keep innovating safely.